All right, so looking at this together, okay, the first one wanted you to come up with a missing reactant. So looking at what we were given, actually, no, I am going to push it up there. Okay, looking at what we were given, we had aluminum and oxygen were our products. So what is this type of reaction? It is a decomposition, good. Okay, which means they needed to be together before, right? So we have aluminum, we have oxygen. What happens when we combine things together again? Crisscross them, yep. So charge on aluminum, according to your periodic table, is +3, +3, +3. What's oxygen though? Minus, he's in group 16. He's 2 away from being a noble gas. So -2. So those would get crisscrossed and you'd end up with the 2 right here and the 3 over here. That's your aluminum oxide. Okay? Then you had to balance it. So looking through here, I have 2 aluminums here. So I'm going to go ahead and put a 2. Nope, just kidding. Not going to do that yet. So I have 2 here, only 1 here. So I know that needs to get changed. But here I have a 3 and a 2. So we're going to get both of those to be 6. So I'm going to double aluminum oxide, which tells me that I need a 4 in front of my aluminum and a 3 in front of the oxygen. So that's it, balanced. Then we had to do states of matter. So states of matter for at least, let's start with the product. So aluminum by itself is a metal. So what? Solid. Good. Oxygen is diatomic. He's a gas. Yep. Okay. So what did you put for the first one? Or what would you put for the first one, do you think? Look at your products. You're making a solid and releasing a gas. So most likely, I would say you're starting with a solid. Yeah, you're just breaking it down. If you put aqueous, obviously, just like I constantly say, I'm not going to count on. All right. Okay. Any questions on number 1? It's kind of been the same process all week this week, so good job with the warm-ups if you've been keeping up with them. All right, so number 2. Number 2 had write the missing products and balance it. So we had, so this is a funny one. It's all long and complicated, right? So we have PbNO3, little 2. We have K2CrO4. So a couple things stand out to me. This stands out to me. Why did I underline lead? Because it's a transition metal, which means because we are, actually, let's take one more step further back. What kind of reaction is this going to be? It's a double replacement, good. Okay, we have 2 compounds, so this one is definitely a double replacement. Okay, so knowing that means you're going to have to recombine twice after the arrow, right? So you're going to have to crisscross charges 2 times. So we do need to know his charge. And he's a transition metal, so we got to solve for it. So first we're going to look up nitrate on your polyatomics. So find nitrate on the inside of your polyatomics. What is the charge of nitrate? -1. How many of them are there? 2. So what's the overall negative charge? What's -1 times 2, you guys? -2. So what does lead have to be to balance it out? A +2. So this one has a +2 right here. So this is lead 2 nitrate. Okay? You guys all writing it down to study for your test later? Okay, good. All right. On the other part, this stands out to me. Why? What is that? It's part of your polyatomics, right? So look up who it is, because we're going to need to know his charge too. It's chromate. What's its charge though? A -2. Good. Okay. All right, so now we're actually ready to move forward with the double replacement part. So I'm just going to kind of form a new line Actually, let me see if I can shrink it. If I can shrink this. Not really. Yeah, we'll just start a new line. All right. Oh, yeah, I can. Okay. All right. So we're going to basically take the lead and the potassium and switch them, right? So we're going to take the lead and the potassium and switch them. So I'm going to end up with potassium recombining with some nitrate. Okay, so we got to worry about charges. Potassium is in group 1. What's his charge? +1. Nitrate, we said earlier, was a -1. So if I crisscross those, do I end up with any subscripts? No. Okay, so the next one we've got was lead, which we said, well, we'll do that in a minute, and chromate. So these guys have to recombine. So lead, we said earlier, had a +2. We figured that out earlier from the reactant side. And chromate, according to our list, had a -2. Right? So with those, we would crisscross those. Do we end up with any subscripts below? No, they cancel each other out. Right? All right. So now we have our equation. Check to balance it. I have 1 lead on the reactant side, 1 lead on the product side. I have 2 nitrates on my reactant side, and only 1 on my product side. So I'm going to go ahead and throw a big 2 in front of this. Okay. And then now we're balanced. That's it. Okay. All right. States of matter. For any double replacement, what are your reactants always? Aqueous, because you have to have 2 things that you can pour into a beaker to mix them. Okay? So aqueous. And then for our products, we have to look these up, right? So look on the inside of your periodic table. Make sure you still have that skill. You're looking up nitrate, which is under the soluble list. You check the exceptions. Are there any exceptions? No. So he is aqueous. Then you would look up chromate, which should be on the insoluble list. He's insoluble unless it's with ammonium, right? NH4. Okay, so he's not with NH4, so this one is your solid. All good? Lots of things to think about. All right. Okay, next, number 3. Number 3, we have what is the molar mass of lead 2 nitrate? So lead 2 nitrate just means that we had that +2. We have nitrate with a -1, so we have a big 2 out here. So it was the one from the problem before. Okay? So you needed to add together the molar mass of lead. So look up your molar mass of lead. Help me out. You guys are doing this with me. What is it? Yeah, okay. Sorry. 207.2. We're going to add it to how many nitrogens? 2 nitrogens, good. Plus, how many oxygens? 6. Okay. So type it in your calculator, get it get it on your screen. Shout out the answer once you got it, and we'll double check it. All right, so I heard him say 331 point what? 208. Can I get a second on that?
Yeah.
Good. All right, what are the units of that? Grams per mole. Awesome. Whoa. Sig figs is correct. Oh, sig figs is not correct. You're right. I should have eliminated those two because of that. Darn it, you win. All right, good job. All right, so the last problem that we have, sorry, I'm totally shrinking this whole thing. All right, so the last problem, I do want everyone to write this down because it's not like the others. It's not like what you have done, okay? There's one extra step in it that you probably skipped. You'll still have the right answer because it happens to be a 1-to-1 ratio, but you had to consider it. So I do want everyone to write this process down. So this question asks you to go from 2 grams of that lead 2 nitrate, okay? And it wanted to know how many atoms of lead there were, right? So we bring grams down to the right. That's where the molar mass goes. So we already solved for the molar mass in the problem before. So we have 331.2 grams per 1 mole of this lead 2 nitrate. Okay, words come down to the right again, where we have 1 mole of this lead 2 nitrate. Okay, but we can't just go straight to atoms because you don't have an atom there. That is a molecule, or it's a formula unit. Sorry, formula unit because it's ionic. So we want to know just lead. So what you can do now is we're going to figure out how many leads there are in that little formula unit. So looking at that formula, how many leads are present? Don't overthink this, you guys. How many PBs do you see? 1. So it is a 1-to-1 ratio that you have to do. If I wanted to do oxygen atoms, what would that ratio have been? A 1-to-6, right? And that actually makes a difference. So I did one where it won't make a difference, just to show you the step. Let me finish this out. So then you would have 1 mole of PB is equal to 6.02 times 10 to the 23rd atoms. Okay? So the special step here is right here. Okay? If you're asked to do atoms within a molecule, you got to think about how many of them there are. All right? All right, so if you plug this in, you should plug it in right now. I'll wait for you guys. So you should be getting, hopefully, by this point, I'm sure my sig figs are wrong. Yeah. All right, 3.64 times 10 to the 21. Okay. All right. So you got it all written down to study later? Yes, Miss Fogel. Cool. All right, moving on. Must be a Friday. So go ahead and look at that little half sheet. You're going to be able to write just a couple things on it. But what will also help you is having your empirical formula steps right next to you, as well as the composition of a hydrate homework page. So I think it was like the percent composition page. So I'll give you guys a couple minutes to get those on when you're done. Okay. So, like I said, you should have like your list of steps for empirical formula next to you, unless you have them memorized. If you do, cool. And then we kind of have already covered, so we covered these notes for percent hydrate. It's on the other side of the empirical formula notes. Okay? But what I want to point out is the hydrate. I think at the top of your page we wrote hydrate and anhydrous salt. And we kind of had a little discussion about if we subtract wet from dry, what does that equal? Right? It doesn't, water. It equals the water, okay? And so that'll be a big concept that we're using. So just a reminder, you can always find your percents of water. And then now that you know what to do with percentages, with the empirical formula, you can go from percentage and figure out an empirical formula, right? Like you could take that, assume a 100-gram sample, put grams, convert everything to moles, divide by the smallest, blah, blah, blah. So you can still do the percentage thing. Today, what I'm gonna show you is that you don't really have to do the percentage thing all the time, but you have that to always fall back on. So, so this stuff isn't going away, the whole idea of the percentage of water, because that's actually how this whole empirical formula thing works. And that's how we find these formulas for your hydrates, okay? But I'm gonna push that one off to the side because we don't need that right now. So I'm going to have the empirical formula steps just kind of sitting right there to refer to. But the homework page that you guys have worked on, we're gonna be able to do number 6 by the time I'm done talking to you guys. All right? So your goal is to do a problem like number 6. So read through number 6 real quick so you can see what the wording is like. All right? So it says a 5-gram sample of, who is that? Copper 2 nitrate, and then it has NH2O. So do you see that it's missing that coefficient? So we don't know what hydrate it is. We have to figure that part out. And it says it's heated and 3.9 grams of anhydrous salt remain from the 5-gram sample. And then it asks, what is the value of N? What is that coefficient value? All right, so do you see what your goal is going to be? And that's the exact same calculation you're going to do in the lab. What I'd like you to do is that, since I'll let you do number 6 in class, I want you to do the same process for number 3 and 4. So just make yourself a little note on 3 and 4 that I want the formula. I want you to tell me what the formula is. Okay? You might have wrote it the other day, but just in case, I just want to make sure you do that for 3 and 4. It's good practice. Okay? The more you do it, the easier it becomes. That's probably the most missed question on our test every single year, okay? Because I give you a data table and you got to be able to do it. So, so just so you know, that's where we're going with this, okay? So now that you know kind of how it's going to be worded, push that off to the side. Let's focus on what you picked up at the door. So, if you'd like to add to your title, what we're talking about are mystery hydrates, right? Mystery hydrates. And that's when we are solving for that coefficient value, okay? So usually in these kinds of problems, data is given to you that uses words like hydrated crystals or anhydrous salt. So you saw that wording in number 6, yes? Did you notice that it doesn't say hydrated crystals? It does not, right? It just says a sample. But we know that that sample is a hydrate because it gives you this formula that's missing the little rest of the coefficient. So, so keep that in mind. The other way that these problems are worded is we give you a data table. So I want to just focus on the data table for a second because that's going to really relate to your lab here next week. Okay? So in our data table, okay, you see that we have a container value. And then I tell you that examples of those containers are either going to be a crucible or an evaporating dish. So we probably won't tell you it's a container. We're going to say massive crucible. Okay? And that's just a little dish that has like a little lid on it. Evaporating dish is an open one. Okay? And so you see the little value that's off to the right, 15.8. Then we have hydrate plus container or hydrate plus crucible. So you notice it got a little bit bigger. Can I figure out how much hydrate I have? How? You guys see that? Yes? Or is he the only one who saw that? You were good? Okay. All right. So you take your hydrate minus container to get just your grams of hydrate. Okay? All right. Then we give you an anhydrous salt plus container. So, again, I can just take my anhydrous salt. I usually do AS, by the way, just to save us room. Minus container to figure out how much is anhydrous. Or I'm sorry, the total. What I mean by That was terrible of me. I'm so sorry. This, what I meant to say, is the total value that's in your data table. So the data number, okay? I see how that would have been really confusing if you had wrote that. I'm sorry. My bad. All right. So basically what I'm saying is that if I take 18.2 minus that 15.8, now I have my actual mass of the hydrate. If I take the 17.8 minus that 15.8, now I actually have my salt that's left over, okay? Okay, but you don't have to do that unless I need those values. The most important thing that you need to have is going to be, you need to know percent or grams of water. So I kind of wrote it right here. This is important. And you need to have a percent or grams of the anhydrous salt. So if you notice from what we just did above on that little data table, we were able to get our anhydrous salt, right? Like this part was okay. But how are we going to get grams or percent of the water? And so if you kind of look right below it on your page, I wrote there a reminder of what we said when we first talked about hydrates. The wet minus dry equals water. So if you have your hydrate and your anhydrate, you have masses of both of those. If you subtract the difference, that's how much wet stuff went away, right? That's how much the water evaporated away. Just like the analogy that I gave you with the wet towel, you weigh it, then you put it in the dryer, you have a dry towel, you weigh it again. The difference between those is how much water got lost, right? So once you have the grams or percent of water, you're running through your empirical formula steps. So you have your empirical formula steps that are right next to you, okay? So looking at your empirical formula steps, if I have grams of water and grams of that anhydrous salt, what step are we starting on? Looking at your notes for empirical formula, where are we at? Step 2. Do you see that? Step 2 says convert grams to moles by dividing by the molar mass. Then you're going to divide all of them by the smallest number, and your answers become your subscripts. So this time, instead of answers becoming subscripts, look at what I wrote on your page. So there's the process. I'm dividing by the molar mass of water right here, right? So dividing the mass of water by the molar mass of water. I have moles of water. I have my grams of the dry salt. So label your stuff when you get the problem on number 6, wet and dry, okay? Your dry stuff divided by the molar mass of the ionic compound. So real quick, on your worksheet, number 6, what is the ionic compound? What am I talking about that we need the molar mass of? Yes, we need we need the copper 2 nitrate part. So we need this part. Do we need to add the waters to it? No, we just want the dry copper 2 nitrate. So that's what I mean by ionic compound. Got it? Okay. So once we have that molar mass, now you're good to go. We convert everybody to moles. Okay, so I have moles of water now, moles of this. I gave you a hint. I don't know if it got cut off on yours. You might have to add that part. But this number should be the smallest number because this is the one we want to equal 1, right? Because remember from your homework the other night, when you divide by the smallest, one of them comes out to be 1, right? That's the one that we want to be the smallest. So if it's not, you should come see me and we can look and see if you messed up your calculations or if the problem is bad, okay? It happens, so just come ask me. So that one will come out to be 1. This one gets you your coefficient, the big number. So once you have these 2 answers, we're on step 4 where they would become the subscripts. Now you end up getting, I kind of wrote it off to the side on your paper, you would write out what the salt is. So this would be the copper 2 nitrate, big dot, and then whatever you solved for as that subscript number. And then you put water, okay? And that's how you would do it. So use this, try number 6, call me over if you need help, and then you can try 3 and 4. The rest of the time is work time, okay? Got it? So knock out, if you have any of the worksheets ready to turn in, you can turn those in today. Okay, if they're not ready, bring them back Monday.